All right. Let's call this polar form of a complex number, which is very similar to what yesterday's notes were called. Let's call, and we never actually talked about polar form yesterday. We'll get into that today. So let's call this part 2. And the video that I posted yesterday, or was it yesterday? Yeah, I called that part 1, although we didn't label our notes that way. So we know what a complex number is. We know how to graph a complex number. We know how to find the absolute value of a complex number. The way that we were writing our complex numbers yesterday was in what's called rectangular form. And today I'm going to show you how to write it in polar form. Okay, so I'm going to teach you how to write a complex number in polar form. Doesn't that sound exciting? I think so too. All right. The complex number z equals a plus bi, in parentheses, let's put rectangular form, written in polar form is z equals r times, open parentheses, cosine at theta plus I times sine at theta, where A equals r times the cosine of theta, B equals r times the sine at theta, comma, r equals the square root of a squared plus b squared, and tangent at theta equals b divided by a. The value of r is called the modulus. Plural form would be moduli. Of the complex number z. So r sometimes you'll hear referred to as the modulus, okay? The angle theta is called the argument. The angle theta is called the argument. Of the complex number z. with theta being somewhere between 0, including 0, and 2 pi . All right, so now we got that down. I'm going to teach you how to write a number, a complex number in polar form. Example 1. Plot z equals -2 minus 2i in the complex plane then write z in polar form. All right, so what quadrant is that going to be in, by the way? Which quadrant? Quadrant 3, because your real part's negative and your imaginary part's negative, right? So we know, we learned last class that the real part goes on the x-axis or the horizontal axis, and the imaginary part goes on the vertical axis. So my real part is at -2, and my imaginary part is at -2i. So on the horizontal axis, I go over to -2. The imaginary axis, I go down to -2, and where they meet is going to be where z equals -2 minus 2i is. Okay, so that forms an angle. So if we start, think about your unit circle and go counterclockwise around, we need to figure out what is the angle of that point, okay? So we have in rectangular form, z equals -2 minus 2i. That's rectangular form. We know the a is the -2 and the b is also, in this case, -2, correct? So a is -2 and b is -2 as well. All right, it's going to be a little confusing at first, but hopefully with a little practice, y'all will be all good. By definition, the polar form of z is r, open parentheses, cosine at theta plus I times the sine at theta. So we need to determine the value of r. Which again is the modulus. And the value for theta, which again is also referred to as the argument. Okay, so first thing we're going to do is find the modulus. This is our modulus right here. Also the radius, right? From that point, if we had a circle, that would be the radius. That's what we learned how to find yesterday. Basically, the distance from our point Z to the origin, that's what we did in yesterday's notes. Right on? So we're going to do that first. Everybody cool so far? Am I going too fast? All right. To find R, the modulus, we use R equals the square root of A squared plus B squared. In this case, we know A is equal to -2 and B is equal to -2. So we have R equals the square root of -2 quantity squared plus -2 quantity squared. That is R equals the square root. -2 quantity squared is +4 plus -2 quantity squared is +4. Well, that gives us the square root of 8. Is 8 a perfect square? No, but does 8 have a perfect square factor? Yes, it does, right? So we know how to simplify radicals. If you have a perfect square factor, you need to simplify that. So would you agree that the square root of 8 is the same thing as the square root of 4 times 2? And I chose 4 because 4 is a perfect square. And if we have a perfect square, we need to take the square root of it. So what's the square root of 4? 2. So 2 goes outside the radical. This 2, square root of 2, 2 is not a perfect square. It would be a decimal. We're not doing decimals, so just 2 square root 2. So this is my value of R, the modulus. So for polar form, we needed to know R, right? We found that. Now we got to figure out what's the cosine of this point right here and what is the sine of this point right here. So that's the next thing we're going to do. We've already found the R. So we found the first part. Everybody cool with that? The modulus. All right, I am to the bottom of my paper, so I'm going to continue this on the next page. All right, so to find theta, we use tangent of theta equals B divided by A, with A equals -2 and B equals -2 in this case. Okay, so tangent at theta equals -2 divided by -2, because I should have put B over A equals. So B is -2, A is -2. -2 divided by -2 is what? 1. All right, so we could do this one of two ways. We could draw our unit circle. And in quadrant 1, our 30-degree angle has a tangent of square root of 3 over 3. Sorry. Our 45-degree angle has a tangent of 1. And our 60-degree angle has a tangent of square root of 3. Okay, but is our angle in quadrant 1? No, what quadrant is it in? 3. Okay. Okay. So it's going to be directly across from this angle here, right? That's where z equals -2 minus 2i is, correct? So this angle here would have a reference angle of what? Reference angle right here. What's this angle? 45. Is this 45-degree angle? Okay. So what would be the measure of this angle? 180 plus 45 is 225, right? Also, what we could do is, in our calculator, if we know the tangent of theta is 1, but we want to know what theta is, how could we do that in our calculator? If we know the tangent, but we want to know the angle, what do we use? Inverse, right? So if I do 1, don't hit tangent, inverse of tangent, oops, I did the wrong thing. 1 inverse, I get 45 degrees. Well, that's not, this angle is not 45 degrees, correct? We know it's in this quadrant, but that at least we know the reference angle would be 45. Like if I forget, and I don't want to do the math to find the tangent of all these numbers, right? I know you have the unit circle in your notes, but will you be able to use that on a test? No, that's another thing that we could do to help us figure out what this angle is. Okay, so our theta is 225 degrees. Or in radians, we would do 225 degrees times pi over 180 degrees, which that would reduce to 5 pi over 4. So if we want it in degrees, 225, we want it in radians, 5/4 pi. Tan, hour, yes. Because so the 45-degree angle in the first quadrant, okay, has a tangent of 1. So an angle directly across from it's going to have the same tangent. If you go back and look at your unit circle, they kind of line up like that, okay? Or in our calculator, if we know the tangent of theta is 1, but we want to know the angle, well, we would do the inverse. That's 45 degrees, but we know there's not a 45-degree angle in quadrant 3. That would be the reference angle, okay? So on these, it's helpful to plot the rectangular form so you know what quadrant it's in. Know what I'm saying? To help you. So I believe we have everything that we need to write in polar form. All we need to know was the modulus, which we found, that's the R, and the argument, which we found was 225 degrees, or 5/4 pi in radians. All right, so just as a refresher, polar form is Z equals R, open parentheses, cosine of theta plus I times sine at theta. So if we were doing degrees, you would just do whatever the directions ask for. You have Z equals, the modulus, or your R, was 2 square root 2, open parentheses, cosine of theta. We don't simplify it. You literally just write cosine at 225 degrees plus I times the sine at 225 degrees. That's it. No simplifying. Don't multiply it all together. Don't put this in your calculator to find the cosine and the sine. You just put the angle measure in and the modulus in. If they ask for it in radians, Z equals, modulus is still 2 square root of 2 times cosine of 5/4 pi plus I times the sine of 5/4 pi. Boom. That's it. Hardest part's figuring out what is the angle. What's your theta? Your arguments. Coolio? Y'all ready to do another one? All right, I think I'm gonna do the next one on a whole one sheet of paper. So I got plenty of room left, but I'm going to sample 2. Plot -3 times the square root of 2 minus 3i times the square root of 3 in the complex plane then write Z in polar form period. Express the argument in radians and degrees. All right, so let's see. What quadrant is this going to be in? Quadrant 3 again, because A is negative, your real part's negative, and your imaginary part's negative, correct? Okay, so And I mean, we don't have to be so precise. It's most important to know what quadrant we're in. But negative 3 square root of 2, let me just see. Negative 3 times 2 square root is, that's at like negative 4.24 approximately. And my graph looks kind of crazy. And negative 3 square root of 3, 3 negative times square root of 3. Let's try this again. Do the square root of 3 times negative 3 is negative 5.96. So again, I mean, as long as we know which quadrant it's in, that's the most important part, okay? So in rectangular form, I have negative 3 square root of 2 minus 3i square root 3. That's rectangular form. I want to convert it to polar form. So first thing I'm going to do is find the modulus, which is r. We know in this case, a is negative 3 square root 2. And b, you don't put the I when you say what b is, correct? So just b is negative 3 square root 3. You don't put the I in there, but it is negative. So to find r, which is the distance from the point to the origin, you take the square root of a squared plus b squared. Now we've got radicals, so that's all right, no big deal. Let's do the square root of, using my parentheses, negative 3 times the square root of 2 quantity squared plus negative 3 times the square root of 3 quantity squared. Now you can try just putting all this in your calculator, but be careful because there's a good chance that you're going to make a mistake, okay? So negative 3 square root of 2 quantity squared, doesn't that just mean negative 3 square root of 2 times negative 3 square root of 2? So I would, if you're going to use your calculator, cool, but I would kind of check myself just doing it out by hand as well. I'm going to come over here to the side where I have some room. So negative 3 square root of 2 quantity squared means negative 3 square root of 2 times negative 3 square root of 2. When I multiply and I have radicals, multiply the coefficients together. That's on the outside. What's negative 3 times negative 3? Positive 9 times the square root. Multiply what's under the radicals together. 2 times 2 is 4. Well, isn't 4 a perfect square? What's the square root of 4? Times the 9 that's on the outside is 18. So r equals the square root. When I did a squared, I got 18. Let me see if I can try and put that in my calculator without making a mistake. Parentheses are going to be important. Open parentheses, 3 negative times 2 square root, close parentheses, squared. Oh, I did it. I don't trust myself. When you have the negatives and the radicals and the squared and stuff, I myself would prefer to just work it out by hand. I just don't trust that I'm going to enter it correctly in the calculator. But it's good we checked both ways and we got the same thing. So I'm pretty sure 18 is correct. So with b squared, negative 3 square root of 3 quantity squared. So that's negative 3 square root of 3 times negative 3 square root of 3. Multiply what's on the outside together. Negative 3 times negative 3 is 9 times the square root of 9. Well, 9's a perfect square. What's the square root of 9? 3 times the 9 that's on the outside, 27. Let me just try it in my calculator. Open parentheses, 3 negative times the square root of 3, so 3 square root, close parentheses, squared. Yes, got the same thing. So now we have 18 plus 27 is 45. Is 45 a perfect square? No. Does 45 have a perfect square factor? Like where we could simplify this? Yeah. What factor, if we're not sure? Let's see, 45 is 5 times 9, 5's prime, 9 is 3 times 3. Well, if I've got two 3's, that makes a perfect square, correct? So 45 is the same thing as 9 times 5. Since we have a perfect square, we got to take the square root. What's the square root of 9? 3 times the square root of 5 is not a perfect square. It doesn't have a perfect square factor besides 1, so we just leave it under the radical. Okay. So we have our R. Now we got to figure out what is a theta of this circle. So we'll probably figure out what the reference angle is, right? And go from there. Let's see what we have. So now find the argument, which we know that's what we refer to theta as, using tangent of theta equals b divided by a. So the tangent of theta equals b divided by a. In this case, b was -3 square root 3 divided by -3 square root 2. Okay, well, -3 and -3 are both not under the radical, correct? So we can reduce those. -3 divided by -3 is +1. Well, we don't need to put a +1 on the outside. So that leaves us with the square root of 3 over the square root of 2. And we know we don't like to rationalize, or we don't like to leave a radical in the denominator is what I meant to say. So we have to rationalize. So we're going to have to multiply by what fraction? Square root of 2 over square root of 2. So that gives us, in the numerator, what do we have? Square root of 6 over square root of 4, which equals 2. Now, can I divide 6 into 2 or 2 into 6? No, because it's not 6, it's the square root of 6, right? So tangent at theta equals the square root of 6 over 2. Well, I don't remember that being a common tangent on a unit circle. Do y'all? No. So let's just use our calculator. If I know the tangent, how do I find the theta? Inverse. So inverse tan of square root of 6 over 2. So my calculator, 6 square root divided by 2 equals, and then I don't want tangent, I want the inverse, so that's green, second tan, and I get, let's call that 50.8 degrees approximately. Well, is that what that angle measure is? 50.8? No, that's the reference angle, right? Because we know it's got to be greater than 180 if it's in this quadrant and it's positive. So that is the reference angle, 50.8 degrees. Okay, so is that what theta is? No. So theta is 180 degrees plus 50.8 degrees, and we get 230.8 degrees. Now that's in degrees, right? And then if we want to convert that to radians, we do our degrees times pi over 180 degrees. And we get 230.8 pi over 180, which if that didn't have the 0.8, we could reduce that nicely, right? Yes? I do? No problem. You're welcome. Chrissy, do you want to, oh, you got it. So I wouldn't leave my answer like this with that decimal in it. She said attendance, Carissa. There you go. You're welcome. Have a good day. Thanks. So I would not leave it like that. I would just turn this into a decimal. So 230.8 divided by 180, and I get approximately 1.28 radians. Pi radians. 1.28 pi radians. Sorry, I forgot my pi. That makes a difference. So, but I wouldn't want to leave it like that probably. I wouldn't want to put cosine of 1.28 pi. So in radians, is pi 3.14 or 180? .14. So 1.28 times 3.14, and I get 4.026. That doesn't make sense. Hold on, I'm questioning myself now. 230.8 divided by 180. No, no, it does. Never mind. I'm good. This is good. Making myself look silly. Okay, so now we have everything that we need in order to write our write it in polar form, right? So if we want to do degrees, you say z equals your modulus, which was 3 times the square root of 5, open parentheses, cosine of, that was 230.8 degrees, plus I times the sine of 230.8 degrees. If you want it written in terms of radians, z equals 3 times the square root of 5 times cosine of 4.026 plus I times the sine of 4.026. Coolio? All right, I have 2 more to do, but we might only get to 1 more. Is everybody good with this? All right. And if you did leave it in terms of pi, if this was a multiple choice, you would just look at your options. If they did leave it in terms of pi for the radians, you would want to make sure you put 1.28 pi. If you put your in terms of a decimal form, then 4.026, there wouldn't be a pi there, right? So it just depends on what they ask for. If it's not multiple choice, then just, you can do either. They mean the same thing. All right, so example 3. Same directions, z equals -2 plus 2i times the square root of 3. Okay, so what quadrant is this going to be in? Second quadrant, because your real part's negative, your imaginary part's positive. So that's going to be somewhere in quadrant 2. Let me see what 2 times the square root of 3 is. 3.4, so 1, 2, 3. So your real part is at -2. And 2 times the square root of 3 is approximately 3.4. 1, 2, 3.4. So I'm going to be somewhere about right there. Okay. So I need to figure out what is r, the modulus, which is the distance that my point is to 0. And I also need to figure out what theta, or the argument, is. That's 2 things we need to know. Coolio? All right, so let's do r first. We know that a is -2 and b is equal to 2 square root 3. We don't put an I in there. It's just 2 square root 3 times I is 2i square root 3. So we know r equals the square root of a squared plus b squared. So r equals -2 quantity squared plus 2 square root 3 quantity squared. R equals the square root. What's -2 quantity squared? 4 plus, let's see, 2 square root 3 times 2 square root 3 is going to be 4 square root 9, which is what? 12. Because the square root of 9 is 3 times 4 is 12. Y'all cool with that? So that is the square root of 16. Oh, 16 is a perfect square. What is the square root of 16? 4. So we know the distance that point is to 0, also known as the modulus, is 4. Well, now we have to find the theta, or the argument. And we know we use the tangent of b divided by a. Because we know tangent is y over x. So we think of the imaginary part as like the y, the real part is like the x, right? That's why we use the tangent of b over a. So the tangent of theta equals b divided by a. In this case, b is 2 square root 3 divided by a is -2. Well, I can do 2 divided by -2 because they're both outside of the radical. So what is 2 divided by -2? -1, and that's going to be outside the radical, or I can just say negative square root of 3. I don't have a radical in the denominator, right? Because my denominator now is just 1. So I know the tangent of theta, but I don't know what angle theta is. So if I know that tangent of theta is negative square root 3, how can I find theta? Inverse tangent. So inverse tangent of negative square root of 3. Let me use my calculator. So let's do 3 square root, make it negative. I don't want to know tangent, I want to know inverse of tangent. So second tan, and I get negative 60 degrees. So is my theta 60 degrees? No, that means that my reference angle is 60 degrees, right? And it's negative 60 because in that quadrant, a positive divided by a negative is going to be a negative, correct? Okay, so what would be my theta? How do I find it? 180 minus 60, and I get 120 degrees. So that's my theta in degrees. I'm going to write it both ways. So in radians, we take your degrees times pi over 180 degrees. Oops, sorry, I can't see that. So we know degrees will cancel. They're both divisible by 10, so that leaves us with 12/18, which would reduce to 2/3. So 2 pi over 3. We could leave it like that, or since it's in radians, so it's either 2 pi over 3, or if I want to write it as a decimal, what do I do, 2 times 180 or 2 times 3.14? If I want to convert it to decimal form, but still in radians, I would multiply by 3.14 because that's what radians is in, or that's what pi is in radians, right? If it was degrees, I would do 2 times 180. So 2 times 3.14 is 6.28. Divide that by 3, and I get 2.09 radians. So either 2/3 pi or 2.09. You could see it either way. So I'm going to write it both ways this time. When I do my polar form in radians, I'm going to do both ways. So polar form in degrees, we would have z equals my modulus, which was 4, open parentheses, cosine of theta, which in degrees is 120 degrees, plus I times the sine of theta, in this case, I times the sine of 120 degrees. Then I'm going to do radians in terms of pi. On the last one, we just did it in decimal form. I'm going to do both this time. So that's z equals 4 times the cosine of, in terms of pi, was 2/3 pi, plus I times the sine of 2/3 pi. Or if we do radians in decimal form, we would have z equals 4, open parentheses, cosine of 2.09, plus I times the sine of 2.09. I know this is in radians because it doesn't have a little degree symbol. Notice when it was in degrees, it had a little degree symbol. Right on? Okay, thank you, Tristan. Thank you for letting me know. We good to go? So I have one more. Remind me next class if we need a review, and I can do the 4th one with you. But are we good? The hardest part really is just finding an angle. All right, so we're done with notes today. And next class we'll do, and tomorrow we'll do an assignment, okay?